take water as much as possible near the surface because from a short period of time, and the other type is in the tropical area and have a lot of water in the ground, so it has to go down.
Yep, Dino, that was an absolutely fantastic explanation. What is the difference between, tell me.
Because one is in dry area and
Okay, who can tell me why some leaves will be thin and small like needles, whereas some leaves will be big and wide? What can you tell about those situations? Yes.
Some leaves are thin, so they don't lose because they live in the desert and they don't want to lose, so they cannot. They lose less water.
Yep, perfect. Good answer. Sunlight then is needed by other plants. Maybe they need to grow bigger and stronger. Always think about this, the size of the leaf as well. Think about how big a leaf can get a tree compared to another type of leaf. Yes, thank you, Emily. Yes, Laura. So what about waxy leaves compared to big leaves? Why do you think some leaves are waxy? Pizza.
Because the water can't get into the leaves, so it would be like a wet tea, because the function of the leaf is not to absorb water. It's the roots function.
Yep, cool. Very good answer, Pizza. Good job. Okay, let's try another question. Why do some plants have defensive mechanisms like thorns or spines and some other plants don't? Why do you think they need it? Let's choose someone different. Who have I not heard from? Let's go, Jasmine. Jasmine, why do some plants have thorns and spines, whereas some plants don't? Right, Bill. Bill, why do you think some plants need to defend themselves?
because if they are in a period that have animals, it can have their protection, so the animal can't eat them or.
Yeah, no, that's fair enough. I'm going to ask another question. Now, this is going to be taking it a next step, okay? So, why do some plants grow fruit? Why do some plants not grow fruit? 23, why do some plants grow fruit, but some plants don't grow fruit?
So people and animals can eat the fruit.
Okay, yeah, people and animals can eat the fruit, but why? Why?
I don't know.
I don't know. Okay. Let's go for Dino. Okay, Dino, why do you think some plants make fruit, some don't?
I think they make food so they can make so animals can eat them and poop out their seeds.
Okay, well, let's not say that word poop. Let's just say droppings, okay? Yes, I think that those plants still have defensive structures to stop plants from eating or stop animals from eating the fruits. Bill, Pingu, do you think a plant still defends against animals trying to eat their fruit?
Yes.
Why?
I had wanted to pick a grape, but the branch has spines, so I can't take the grape.
Okay, yeah, that's a good example. Who can think of another fruit that has some kind of spines? And why do you think the fruit has spines? Monkey.
Like a durian.
A durian, okay. What about a durian is a defensive mechanism?
It has spines. It has like sharp things that when I first time I see it is sharp. It's
okay.
sharp.
Okay, cool. Lily, can you think of another fruit that has some kind of defense mechanism?
Blackberry.
A blackberry, cool. Tell me about a blackberry.
A blackberry bush has thorns, so it protects the blackberry from being eaten by wild animals.
Okay, so very good. Now, this is all when the fruit is still attached to the plant, right? So let's think about this. What does a fruit do, or what does a plant do to a fruit when the fruit is ready?
A jackfruit.
A jackfruit. Okay. What about a jackfruit is a defense mechanism? So Emily, what do you think a plant is saying when it lets the fruit drop to the floor?
I think it is saying, I am ripe now. Eat
Yes,
me.
exactly. So the plant has said, you know what? This seed, this fruit is ripe. Until now, I was protecting it. I was keeping it safe from being eaten from animals because it was not ready. It was not good to go. Why would a fruit not be ready? Why do you think a fruit needs to wait in order for it to drop first?
If we eat a fruit that is not ripe, we will have a bellyache. So the plants don't let us have a bellyache.
Okay, Pencil, your hands up. Why do you think plants wait until the fruit is ripe to drop? No, that's not right. Monkey, what do you think?
I think that plant is not fertilized, and they have to wait until the plant is fertilized and it forms into a fruit and seed.
Yeah, okay. So I think you're about 50% correct there. So the plant is worried that the seed is not ready, okay? When the seed is ready and the plant is ready to completely reproduce and get the seed sent to somewhere else so that it can grow in a different place, then it's going to go, okay, hold on. Now the seed is ready. Now I'm going to drop my seed and now it can be moved. Until now, I don't think it is ready yet. So that's what a plant is going to do. Okay, I'm going to share my screen. We're going to go through some experimental based questions today, okay? Okay, can you all see my screen? And can you all read what is on the screen as well? So a hydrilla plant is placed in a brightly lit room as shown in the setup below. So here we have a filter. On top of the filter, we have a glass tube. Then we have water, we have pond water, and we have the hydrilla plant underneath the funnel. Now, remember that this is in a brightly lit room. What does brightly lit what does brightly lit room mean? What does that mean?
It has 100% light.
Okay, yeah, okay, fine. So yes, a brightly lit room means that there is a lot of sunlight. What do plants do with sunlight? What do
The plant takes from sunlight energy and food.
Okay, so the plant takes sunlight and creates energy in the terms of food. Now, what happens when a plant makes food? There's a gas released from plants when it makes food, Kent. What is the gas that comes out of plants?
It makes food and oxygen.
Yes, it makes food and oxygen. Good stuff. Now, when when a plant is making oxygen, what's going to happen is here. So what you see is that as the sunlight comes in, it comes in and hits the plant, and the plant takes in the sunlight and it makes food and oxygen. What happens is that the water in this test tube will be moved, because as the oxygen goes up to the top and more and more and more and more and more is created, the water in the test tube is going to go. The plant releases water and more water is collected in the test tube. The hydrilla plant takes in oxygen and less carbon dioxide is collected in the test tube. The hydrilla makes food and produces oxygen, which is collected in the test tube. The hydrilla plant makes food and produces carbon dioxide, which is collected in the test tube. Looking at all of those answers, who can tell me which one they think is the most correct?
I think number 3.
Number 3. Why do you think number 3?
Because The plant is in a brightly lit room, and the test tube is made of glass, which is transparent, and water is also transparent. So the hydrogen pan has water and sunlight to make food.
Yeah, perfect.
And
Yeah, so as the plant collects the sunlight from, as you said, the brightly lit room, we have water, which is transparent. We have glass, which is transparent. Both of these allow sunlight to pass through onto the plant. The plant collects in the sunlight, makes food, and it makes oxygen. Remember, when we talk about matter, what is matter? Matter is something that takes up space, okay? Gas is a phase of matter. Even gas has a size or has volume. So when the gas is created, it bubbles up through the top of the test tube, up through the water, and at the top you then get oxygen. Think about this, right? Who has ever got a can of Coca and shook the can of Coca and then opened it really fast? What happens when you open it up really fast?
explode.
It explodes, right? So the gas inside the Coca-Cola is full of what is called, is full of carbonated water. So carbonated water is fizzy. What it does, it releases bubbles of carbon dioxide throughout the Coke to keep it fizzy. Now, when this happens, what happens is the carbon dioxide will start at the bottom and it works through the top. When you shake up a can of Coca, what happens is the carbon bubbles, they start taking up volume and they make the can bigger. So when you open it, all of the pressure of having all of that gas and now all the liquid inside the can makes it explode, okay? So when you think about a plant underneath water, it's making little bubbles of oxygen, like that carbon dioxide in the can of Coca. So what's happening is it's coming up and it's pushing the water down. So it goes up to the top and pushes the water down. Same as in a can of Coca, except without the explosiveness. Yes, Emily. What you need to remember is that in this experiment, the point of the experiment is to see how much gas can be released from a hydrolia plant if it is left in sunlight to create food. It creates food. One of the byproducts and one of the products of when a plant makes food is it makes oxygen. The oxygen is then stored here. So the oxygen pushes the water down, and here we go. So the hydrolia plant releases water. Does a plant release water? Just shake your heads if you think, or nod your heads if you think a plant makes water. Plants don't make water, right? They absorb water, they need it, they don't make it. So again, if you were looking at this question in a test, look at what the question says. It releases water. That's not true. The hydrolia plant takes in oxygen. Do plants take in oxygen? No. What do plants take in? They take in carbon dioxide. So no, that answer would be incorrect as well. Now, last one. The hydrolia plant makes food and produces oxygen, which is collected in the test tube. Even if you did not understand that oxygen is going to get collected at the top of this test tube, you know that this statement, the hydrolia plant makes food and produces oxygen, is correct, right? That is a correct statement. So even if you didn't fully understand what the question had been asked of you, if you look at all of the answers, you're going to find the right answer anyway by using what you know. Letters. What we have here is a table to try to represent. Who can see letter A? What do they think is going into the plant at letter A? What do you think it is?
I think it's water
Okay, so let me ask, why do you think it's water?
because the roots absorb water from the ground, then move the water up to the other parts of the plants to help the plants make food.
Yeah, perfect. Great answer. Really good. So, as Lucy and Monkey said, it's water, because what you see here is, look at the direction of the way it's going. It's going from the bottom and it's going to the top. We know that food is going to go the other way. So water will always go up and up the tree. So what is letter B Who can tell me what letter B is? Carbon dioxide is,
Carbon dioxide.
yeah, carbon dioxide is going to go in at B. That's where we're going to start picking up the carbon dioxide we need to start making the sugar. Okay, what about C? Who can guess what C is? Yeah, Minnie.
I think it is oxygen.
Yeah, I would agree with you as well. So we know that plants release oxygen after they make food. So they take in carbon dioxide, but they release oxygen. Yes, good stuff, Minnie. Oh no, go back. And what about D? What do you think is going to happen at D? Yeah, sugar. Yeah, good stuff, buddy. Well done. So yes, sugar is made in the leaves and then it is transported around the plant. Okay. And last one, E. E is the really super easy one. I don't think there's any issue here whatsoever. Jasmine, what's E?
Light.
Yeah, E is light. Good stuff. So those are all the those are all the parts of the plant and access areas. Remember that when a plant is making food, it needs sunlight, it needs carbon dioxide, and it needs water. It absorbs energy from the sun to biosynthesize to make within itself a sugar, which it then transports around the plant. So was can't remember who said roots. I think Lucy, the water comes up from the roots, goes around the plant. Sugar is made in leaves, which then goes around the plant as well. Remember, water can only go up and only go up. You'll never see plants bringing water down. They only absorb water in the roots, nowhere else. Remember that, okay? Okay, this next question. It's a little bit outside the box. What I want you to do is, I'm going to read it to you. I'm going to see what you think, okay? Not going to help you too much. Two setups were left in a room as shown below. You've got beaker A and you've got beaker B. In beaker A, you have a plant. You also have a layer of oil and 200 milliliters of water. You have a fair test because the same amount of water and the same amount of oil is in beaker A and beaker B. The variables are completely the same. Now, line A in the graph below shows the amount of water in beaker A after 5 days. Which line most likely represents the amount of water left in beaker B? So who can guess which one it is? P, which line do you think represents beaker B? P, 1, 2, 3, or 4?
3.
3, why 3?
It's 3 because because it is more waters, the volume of waters on the day.
Okay. Who thinks it is a different one? Elsa.
1.
Why is it number 1?
There is no objects to absorb in the water.
Elsa, I would agree with you. I would think that it is number 1 purely for the fact that if you look at the graph for beaker A. Now, in beaker A, we can see it started on 200 milliliters. Now, after 5 days, it went down to about 120 milliliters, okay? Now, we know that a plant absorbs water. That through its roots, it's going to take water and the water that it needs in order to grow, right? Remember the flowers we grew in class. We didn't use water, but we used cotton buds. But what happened is the cotton buds got dry. The roots sucked up and absorbed all the water in the cotton buds in order for that plant to then grow. In this experiment in beaker A, you've got a plant. We know a plant needs water and a plant's going to grow. In order to do that, it's going to absorb water from wherever it is. In beaker B, you don't get much. Now, there's probably someone that can make an argument that through condensation, we will lose some amount of water, but for the purpose of this experiment, we are only going to talk about plants, okay? So from the plant perspective, we have in beaker A, a plant that's absorbing water. In beaker B, there is no plant, there is nothing to absorb the water, as Elsa said. So the answer would be line number 1. the amount of water is not going to change. It's only going to change very, very slightly, due to the fact that there is nothing in beaker B to absorb the water. So this is where your understanding comes in. You need to think, wait, hold on now. I know that that a plant will absorb water. I can assume that in beaker B, as there is no plant in the water to absorb the water level is going to stay the same. What about if there were, let's say, a small plant in beaker B? Rosie, what do you think is going to happen if there is a small plant in beaker B? Which line do you think would show that? Line 3, right? Imagine you had a smaller plant absorbing less water. You probably see line 3. Okay, I want to ask a couple quick questions first. So why can it not be line 2? Who can tell me why it can't be line 2?